So onward to an example of a regression, which is very catty, tongue-in-cheek example, as you'll see, but it does explain the theory well. So this was inspired by a tweet. You may know of the actor Dennis Quaid. He's been around for a very long time and been in a lot of movies, including Parent Trap with Lindsay Lohan, The Right Stuff About the Space Program. He's been around for a long time. You've probably seen something with him in it. And he remarried this year. It is his 4th marriage. And Ms. Amadi on Twitter shared his first wife was 3 years older than he was. His second wife, Meg Ryan, was 10 years younger. His third wife was 20 years younger, and his 4th wife will be 40 years younger. And she jokingly said Dennis Quaid's 5th wife hasn't been born yet. So I was wondering, well, does the data support that quip? Like, is that actually true? So being the stats nerd I am, I decided if Dennis Quaid has a 3rd wife, has she been born yet? Aside, love is love, get yours. Like, I'm not making fun of anyone that's been married multiple times, but I'm just curious mathematically for science. So I started to tackle this problem, and via Wikipedia, I decided to do some research about his wives, his ex-wives, the wives' birth year, Dennis Quaid's birth year. As you can see here, I graphed out a bunch of stuff. Year of divorce, difference between ages, age at marriage, Quaid's age, just a bunch of stuff. I kind of started gathering data to get an idea, and I decided that I would use wife's birth year as my X variable to predict the year of marriage, the Y variable. So for each ex-wife, I decided to check for a linear relationship between the year that they will be married and their birth year. Remember, X and Y variables matter in regression, so I decided to use the X variable of birth year to predict marriage Y. What is my logic? If it is statistically significant, if it has a reasonable R squared and beta, my data will back up the idea that the year in which a woman is born is a good predictor of the year in which they will or would have become the bride of Dennis Quaid, Mrs. Dennis Quaid. So that's what I'm going to use my regression for. Note, this is all tongue-in-cheek. And note, this is a really tiny sample size, but we're going to run a regression example anyway. And I shared this data. This time it's up in a Google Drive. So this is the CSV file, but you just need the wife's birth year and the year that they were married. So we can even just bust out some Excel if you don't want to download the whole stinking data, which is fine. Don't know if you can hear my kids. They're stomping around upstairs. So I'm going to do, come back, Excel. Birth and married. I'm just going to call my data that. PJ Souls was born in 1950. You might remember her. She was from the Halloween movies. She was like, she had big poofy blonde hair, often in pigtails, in the first Halloween movie with Jamie Lee Curtis, if you are a fan of horror. Okay, so this is our wee tiny data set, right? So it's not reliable because it's a tiny data set, but it's funny. So I'm going to save this guy as my CSV, DQ data, save it as a CSV. And as I do in this class, I'll just save it to my desktop. And I'm going to open it up in JASP. Do just as take a moment and realize that that data entry looks a whole lot like my data entry for correlation, right? 2 columns. And it's kind of understood that for each row is a different research participant. Each column represents one of the 2 data sets that I collected for each individual. So who are my people? Dennis Quaid's wives and ex-wives, and I collected 2 pieces of data, their year of marriage and their year of birth. I could do a correlation on this research as well. Also, as a side note, you can always do a correlation and regression on the same sort of data. What am I doing? I'm doing, again, the regression little screen grab or icon should start to make sense for you. It's like an X and a Y variable. It looks like a little scatter plot. You've done a correlation. Now we're doing linear regression. Logistic regression we'll not be doing in this class. So we've got linear regression, and we're using birth year to predict the year of marriage. So the dependent variable is going to be the Y variable, and the Y variable always goes up here. That's an important thing to remember when you're doing your data entry. The Y variable is always the one that you're using to make the prediction. Sorry. JASP. Sorry. And what are we going to be paying attention to? The null hypothesis model, and the H1 is the alternative hypothesis. We're looking at the H1 model. When you do your regression, it's rather straightforward because all of the information that we'll need, like beta and R squared, is all already in there, and you don't really need to make any plots or anything. So that's what you need for your regression. Just remember, again, I'm going to emphasize this. I'll even color it in here. Sorry. What do you need to know about the screen? This is the Y variable, and this is the X variable. Y is that which you are trying to predict. So what are we trying to predict? The year you get married to Dennis Quaid. What are we using to make that prediction? The year of birth for all of his Ys and X5s. And what do we have here? We have the regular R squared of 0.98. That's what we want. Our correlation's crazy high. Why is it crazy high? We have a tiny little sample, but there does seem to be a pattern. Dennis Quaid. What else do we have in here? We have an ANOVA, which we're going to use. We'll explain that later. And then we're going to use down here the H1 again in order to figure out the correlation regression coefficient. So this is a slightly older version of regression that you're seeing up on the screen, but it still shows you what you need. You need your R squared. From this ANOVA, which you're going to use to describe to evaluate your research, you need that F and P value. And down here, again, this would be under H1 in your data. You're going to have the wife's birth year and the intercept. So this is where you get the regression equation from. Intercept is indeed the Y-intercept. So on this graph and in the equation, the Y value, where the line hits the Y, the intercept value is always labeled as intercept. Under unstandardized, the thing below it where it says wife's birth year and it's 0.95, that's your slope. So they aren't labeled as clearly as they could be for our purposes, nor does JASP just spew out the equation for you. But the equation is there for you. And I could always make it a little clearer here. This is the Y-intercept, which is equal to A in the equation. And this is slope, which is equal to B in the equation, just to be clear. Always look under the H1 variables. Intercept is always labeled intercept, which you just have to remember that the other one is just the slope. What else do you have down here? See where it says standardized? Remember how we were talking about beta is standardized slope? Here is beta, and the beta here is 0.99. So for every 1 unit change in X, there's a 0.99 change in Y, which is a really big beta. And your R squared, again, is enormous, which means that there's a lot of shared variance. And that T and P are going to become important later. I'm going to clear my drawings here, but you can always screen grab this or return to the video for those notes. I made my own little scatter plot of what the data looks like with the picture of the wives there. Indeed, it's a strong relationship. However, it's spurious because it's such a small sample size. Generically, what would you do to report a regression via APA? Method result discussion, your old friends, right? Method, what data did you collect? Which variable is being used to predict which variable? Results, a regression was conducted to predict whether or not X predicts Y, but put in the names of the variable. That's a good thing. And you're going to describe, basically, when you do your write-up, you're going to describe beta and R squared. And this is how you describe it. This is the data that you use. And you can mix and match going back and forth between your output and this in order to write up your regression. One thing I'm going to be a stickler about when you do your regression write-up, do make sure that you use that prediction language. So if you have big beta, big R squared, then X predicts Y. And if those p-values are significant, that backs up that argument, or it doesn't. Here's how I would do the write-up. Dr. Hartnett gathered the data about Dennis Quaid's wives, including information on their birth year and age, as well as the year in which she will or would have married Dennis Quaid. I did this before he married his latest wife, which was in 2020. The researchers performed a regression testing whether a woman's birth year could predict the year she married Dennis Quaid. So when you would do a results section, you'd be talking to other people who get regression, and you're just being very clear on the direction of that relationship and what your X and Y variable is. The regression, that should be the regression determined that the relationship had strong predictive power because your beta was good. So X predicts Y, and the birth year explains a significant portion of the variance. It should say like the variance in Y. So the research suggests that women's birth year is a strong predictor of when they'll marry Dennis Quaid. Where does the prediction come from though? The prediction comes from under the coefficients in the H1 model. Again, you have your slope and your y-intercept. And if this is the regression equation, broadly, this is the regression equation where a year of marriage would be predicted by 133.86 plus after multiplying 0.9 by the y for x5's year of birth. So I was born in 1979. I'm still 41, not for longer. Birthday's in April. You're an instructor. I missed my chance. I would have married him in 2013. Getting a little too old for Dennis Quaid. So sadly. So again, that's when I would have been predicted to marry Dennis Quaid. And that's where, again, regression is about predictions. We have all this past data explaining Dennis Quaid's marital behaviors. We have all of this data from the past. Therefore, you could take my birth year or your own birth year. That would be good practice, y'all. And see what year you would become Mrs. Dennis Quaid, or someone your age would become Mrs. Dennis Quaid. To return to that original question from the Twitter, I did this in 2020, I think still applies. So the year's 2020, the year of marriage, again, would be intercept plus slope times wife's birth of year. So they asked, would she have been born yet? Dennis Quaid's fifth wife. So let's say 2020 is our cutoff year, which means someone born in 2020 would marry Dennis Quaid in 2052. That's a while from now. Given the pattern and the fact that I love tracking down data, Quaid would have to remarry in 2052 in order to marry someone who's not been born yet. Dennis Quaid will be 97 by then. The average life expectancy for a white American male in California is around 77. So it is possible, but unlikely Dennis Quaid will live long enough to marry someone who's not yet been born. So I don't think that the data supports the quip. That's one way of looking at it. And I will go over this next example in a third video. But that is the basics of how you would run a regression and do the APA report for a regression.